solving trig equations. So when we were just dealing with angles between 0 and 90, it was fairly straightforward. But now we've seen this idea of angles of any magnitude. We have to take into account other possibilities. So a question like this, tan theta is now a negative number. Oh, hang on a sec. So we have to think about, which quadrants are we in? What are we talking about here? So usually they will tell us to find answers in a certain domain. So 0 and 360 is what we'll be using here. And that's usually the most common one because, go around the circle once, get all the possible solutions. So the first thing we do, locate the quadrants. Well, we know tan's negative in the second and the fourth quadrants, so righto. But then we work out the equivalent acute angle. So if I'm finding the acute angle, I don't worry about the negative. So tan alpha is 2.3673, I get the answer 67 degrees 6. And so now I put all that information together. Well, I've got to go and solve it. Well, I'll just draw myself up a little diagram there. So I know I'm in the second quadrant and the fourth quadrant. So the second quadrant, that was our 180 minus alpha, so minus the acute angle. And the fourth quadrant was 360 minus the acute angle. So we put it all together and we get our two possible answers, 112.54 and 292.54. So cos theta equals a half. So same idea. Cosine's positive, so that would be the first or the fourth quadrants. So I just draw up a little diagram there, righto. So I know it's going to be the acute angle in the first quadrant, or 360 minus. Well, let's find that acute angle. 60 degrees, of course, because half's one of our exact ratios. Should have seen that one straight away. Okay, so we'll have that acute angle, or 360 minus the acute angle. We get 60 or 300. Cosec. Well, of course, we don't have a cosec button on our calculator, so first thing I'm going to do is turn it into sine. So turn it upside down. We're solving sine theta is a quarter. Well, sine's positive in the first and the second quadrants. Find the equivalent acute angle, that's 14 degrees 29. Put the information all together, well, we're either going to have the acute angle or 180 minus the acute angle for the second quadrant. And so there's my answers, 14 degrees 29, 165.31. Well, sometimes they try and make it look harder, but it's still the same idea. Remember, it's an equation. So you want to make what it is you're finding the subject of the equation. Now when you're dealing with trig, it's not like you can pull the x out of the trig. It's not like factorising or expanding. So we've got to get sine x, the subject of the formula, first. So we get sine x is negative half, then we can go and find x. Okay, so third and fourth quadrant in this case, sine's negative. My acute angle would be 30 degrees. So it's going to be 180 plus the acute angle, or 360 minus the acute angle, and we get 210 or 330. But now we've seen some trig relationships, some trig identities. So that allows us to solve some further questions. So 5 sine theta is equal to minus 2 cos theta. And so what I can do here is use that relationship of sine divided by cos is tan. So I could change the question to be tan of theta is minus 2/5. And that's one of our straightforward ones, so I can just do that. Well, quadrant 2 and 4, tan's negative. Acute angle will be 21.48. So 158.12, 338.12, my two possible answers. The only thing we have to be careful with, if we change the original question, which effectively is what I've done here. I've said, well, look, 5 sine theta equals minus 2 cos theta, too hard. So I'm going to change the question to something I can deal with. And that question was tan theta equals minus 2/5. We just have to be careful because these two are solutions to my new equation. Are they also solutions to the original equation? Now something like this, the answer is going to be yes. Sometimes they will get ones like this, cos 2 theta, possibly it'll still work, but then we can also get other ones where we had squares. And if you square both sides of the equation, for instance, you might create new solutions that aren't solutions to the original equation. So you always just have to keep an eye on it. And if you change the equation, then, all right, are all my new solutions actually solutions to the original question or just the new question that I've created. Here, it won't be an issue because it is just a cosine. It's just that instead of finding theta, I'm going to find 2 theta. But, this is where I have to be careful, theta's going between 0 and 360. But if I'm finding answers for 2 theta, well, 2 theta then has to go between 0 and 720. So I've got to go around the circle twice for this one. Quadrants 1 and 4, that doesn't change. So the acute angle is 41.25. So 2 theta is either the acute angle or 360 minus. But because I'm going around twice, all I've got to do is add 360 to all the answers. So I add 360 to both of those. They're the answers for 2 theta though. We want theta. So the final step is to divide by 2. And that gets all the answers in between 0 and 360, which they want. So we have 4 answers for that one. Here's one like I was talking about. We've now got a sec squared in there. So I'm going to change the question. I'm going to take advantage of the trig identities. I can rewrite sec squared as 1 plus tan squared. And I now have a quadratic equation. It's just our pronumeral is tan theta instead of we're used to seeing x. We still solve it the same way. What multiplies together to give -2, adds together to give 1. So it factorises to give tan theta plus 2, tan theta minus 1. So we've got 2 possibilities to solve. Tan theta is -2 or tan theta is 1. Well, I'll just work out both of those. So -2, that would be second in the 4th quadrant. Acute angle is 63.26. And we find those 2 possibilities. Tan theta equals 1. That's the exact value, isn't it? It's actually 45 degrees, the acute angle. But let's just check. 1st and 3rd quadrant. Yes, sure enough, there it is. Acute angle is 45 degrees. So we get 2 possibilities there. I don't just leave it like that. I now combine it into, right, my final answer is, these are all the possibilities for theta. And in fact, all of those do work for this one. So 6H are just solving some trig equations. I've chucked a handful in from the old Cambridge textbook as well, because there were some nice ones that when we were using the old book that I asked to notice haven't made it into the new edition. So I thought, oh no, we'll still have a look at those because there's some good questions in there.